Hello and welcome to today's topic on linear motion, a Form 2 topic in mathematics under 844 system. This is teacher Kiplagat. Welcome. So the subtopic today is relative speed, and the objectives are by the end of the lesson, the learner should be able to calculate relative speed and do other questions related to relative speed. Welcome. Now, I want us to consider two vehicles moving in the same direction at different speed. Now, the first vehicle on the left is moving at 90 kilometers per hour, which is behind the first vehicle, which is moving at 72 kilometers per hour. Now, these vehicles are moving in the same direction, so the relative speed is the difference between the individual speed. That gives us 90 kilometers per hour minus 72 kilometers per hour. That gives us 18 kilometers per hour. On the other hand, the relative speed when two bodies are approaching each other is the sum of the speed. Again, let us consider two vehicles approaching each other. One of the vehicles on the left side is moving at 25 meters per second. The other one is moving at 25 meters per second. So to get their relative speed, we add the two speed. That gives us 50 meters per second. So when the bodies are approaching each other, then we add their speeds to get the relative speed. And when they are moving towards the same direction, then we subtract the speed to give us their relative speed. Let's look at example 1. A van left Mombasa for Nairobi at an average speed of 80 kilometers per hour. After half an hour, a car left Mombasa for Nairobi at a speed of 100 kilometers per hour. A. Find the relative speed of the two vehicles. And B. Find how far from Mombasa the car overtook the van. So let's begin with A. Find the relative speed of the two vehicles. Now, since they move towards the same direction, so we get the difference of the speed. So the relative speed is 100 kilometers per hour minus 80 kilometers per hour. That gives us 20 kilometers per hour. B. How far from Mombasa the car overtook the van. So before we apply the relative speed, we need first to find the distance which was covered by the van in half an hour. So distance is given as speed times time, and the speed of the van is 80 kilometers per hour times half an hour, which is 30 over 60. So we have converted 30 minutes to hours. So that gives us 40 kilometers per hour. That means the van had already moved 40 kilometers. So when the car started, the van was 40 kilometers away. So that now helps us to find the time and the distance the car took to overtake the van. So that means time taken for the car to overtake the van is the distance over speed. And the distance we're going to use is the distance between them, and the speed is their relative speed. So that gives us 40 kilometers per hour over 20 kilometers per hour. That gives us 2 hours. Now, the distance from Mombasa, we can either use the speed of the van or the speed of the car. So in this case, we are going to use the speed of the car. So 2 hours times 100 kilometers per hour, that gives us 200 kilometers. That means the distance which the car took to overtake the van was 200 kilometers. Let's look at example 2. A motorist left Embu for Nairobi a distance of 235 kilometers at 8 a.m. and traveled at an average speed of 90 kilometers per hour. Another motorist left Nairobi for Embu at 8:30 a.m. and traveled at 100 kilometers per hour. Find A. the time they met. B. how far from Nairobi did the two motorists meet? So the first thing, before you answer that question on relative speed, then we need to consider, are they moving towards same direction or approaching each other? So as we can see, the motorist, the first one, left Embu for Nairobi, and the other one left Nairobi for Embu. That means they are approaching each other. So the time they met. So you can see that from we have Embu and Nairobi at 8 a.m. The first motorist left Embu at speed of 90 kilometers per hour. So we need to get the distance traveled for 30 minutes before the other motorist left Nairobi. So distance, speed times time. So we are going to use speed, which is 90 kilometers per hour, times 30 over 60 hours. That should give us 45 kilometers. That means the first motorist traveled 45 kilometers. So we need to get the distance between the first motorist and the other motorist coming from Nairobi. So we need to know. So the difference now is 190 kilometers by doing 235 kilometers minus 45 kilometers. That should give us 190 kilometers. So that is when we are going to use the relative speed at exactly 8:30 a.m. when the two vehicles are moving. Now their relative speed, because they're approaching each other, we add. That gives us 90 plus 100 kilometers per hour. That gives us 190 kilometers per hour. So time they took to meet each other is distance is 190 over the speed 190 kilometers per hour. That gives us 1 hour. So that means the motorist from Nairobi took 1 hour to meet the other motorist from Embu. So the time they met. So you can either use the time from 8:30 plus 1 hour, or you can use 8 a.m. plus 1 hour and the other 30 minutes, which had been taken by the first motorist. So time they met is 8:30 a.m. plus 1 hour. That gives us 9:30 a.m. How far from Nairobi did the two motorists meet? That means we need to find the distance. Distance equals to speed times time. So 100 kilometers per hour times 1 hour. That gives us 100 kilometers from Nairobi. You can still do the distance from Embu. Example 3. Two towns R and S are 245 kilometers apart. A bus traveling at an average speed of 60 kilometers left town R for town S at 8 a.m. A truck left town S for town R at 9 a.m. and met with the bus at 11 a.m. Determine the average speed of the truck. Okay. So now, the distance covered from 8 a.m. to 9 a.m. by the bus is given as speed times time. So the speed is 60 kilometers per hour times 1 hour. That means 60 kilometers. So we have gotten the distance covered by the bus. So distance between them, it's 9 a.m. so that you can apply the relative speed. So 245 kilometers, you subtract 60 kilometers. That gives us 185 kilometers. That is the distance between them. It's exactly 9 a.m. That is when now we can apply the relative speed. Now, relative speed is the sum of the speed. That means we got that because they are approaching each other. So let the speed of the truck be x, kilometers per hour. So relative speed is 60 kilometers per hour plus x kilometers per hour. That gives us 60 plus x kilometers per hour. Time they took to for them to meet is 11 a.m. subtract 9 a.m. That gives us 2 hours. So time is equals to distance over speed. So 2 hours equals to the distance between them, which is 185 divided by the kilometers per hour, which is the sum of the speed. So we cross multiply. So we find the value of x in that case. So that gives us 2 into bracket 60 plus x equals to 185. You open the bracket. That gives us 120 plus 2x equals to 185. 2x equals to 65 and x equals to 32.5 kilometers per hour. That is the speed of the truck. Example 4. Two towns, A and B, are 80 kilometers apart. Juma started cycling from town A to town B at 11 a.m. at an average speed of 40 kilometers per hour. Mutuku started its journey from town B to town A at 10:30 a.m. and traveled by car at an average speed of 60 kilometers per hour. A calculates from 1 the distance from town A when Juma and Mutuku met. Roman 2, the time of the day when the two met. B, Kamau started cycling from town A to town B at 10:21 a.m. He met Mutuku at the same time as Juma did. Determine Kamau's average speed. So as usual, the first thing you need to know is, are the two fast approaching each other or moving the same direction? So the distance from town A when Juma and Mutuku met. So distance covered by Juma in 30 minutes because the other one started at 10 a.m. the other one started at 10:30. So we need to get the distance covered first. So distance covered equals to 40 kilometers per hour times 0.5 hours. That gives us 20 kilometers. Now, distance between Juma and Mutuku at 10:30 a.m. is 80 kilometers minus 20 kilometers. That gives us 60 kilometers. Let the distance covered by Juma at 10:30 a.m. be x. Therefore, Mutuku will cover 60 minus x kilometers before they met. Note, the time the two will meet or take will be the same. That means x over 40 equals to 60 minus x over 60. Time will be the same. So from there we cross multiply and get the value of x. So when we cross multiply and get the value of x, so x will be 24 kilometers. So distance from town A when the two met was 20 kilometers plus 24 kilometers. That gives us 44 kilometers. So we go to Roman 2, the time of the day when the two met. So time is given by distance or speed. So the distance of the first person is 44 kilometers per hour over 40. That gives us 1.1 hours. When you convert that, that gives us 1 hour 6 minutes. So the time they met we add 10 a.m. plus 1 hour 6 minutes. That gives us 11:06 a.m. Now, let's go to B. Kamau started cycling from town A to town B at 10:21 a.m. He met Mutuku at the same time as Juma did. Determine Kamau's average speed. So, 11:06 a.m. minus 10:21 a.m. That should give us a time taken by Kamau. That gives us 45 minutes or 3 or 4 hours. Speed equivalent is given by distance over time. So the distance equals to 44 kilometers over 0.75 hours. That's conversion of 3 over 4 hours. That gives us 58 2/3 kilometers per hour. Thank you for listening. Mathematics is real. Have a good day. Thank you.